It's Miss Compton. I'm going to help you guys out a little bit with the Unit 4 Part 2 test, circles. I've gotten a lot of questions on the directions, on what you're asked to do. So I'm going to work out A and B. I've changed some of the numbers. These are not the exact answers on your test. Okay, so for A, I'm looking for segment FH. That's my unknown. That's what I need to find. Here's the given information that I need in order to find segment FH. So I have changed the length of AO to 20 and AF to 16. And again, I'm asked to find FH. So I notice that I have a tangent line AO, and I also have a secant AH. So we talked about theorems dealing with finding segment lengths, dealing with two tangents, two secants, a tangent, and a secant. So I have a tangent and a secant. So it was tangent squared equals the outside of the secant times the whole secant. So my tangent is 20, so 20 squared equals the outside, what is outside of the circle for my secant is 16. The whole secant, AH, is 16 plus x. That's the whole entire thing. So now we have some arithmetic to do. So 400 equals 256 plus 16x. Inverse operation, we're going to subtract. 144 equals 16x. Divided by 16, and x equals 9 centimeters. So again, I'm looking for my answer. That's 1 point right there. All of this work is my justification. That's the other 2 points. Okay, so I'm going to use, I could use this information to help with B. I don't have to, but I could. Here, I'm looking for segment AE. I'm just going to call him Y. So AE is Y. Again, I know AO is 20. I know AF is 16. I found HF, so I know that's 9 now. But I also know that AL, this secant there, is 36. The whole entire thing. So I have, again, if I knew what EL was, I could kind of use the same that I did for A. The same theorem, the same steps. But I don't know what the inside of my secant or line segment EL would be. So can't really use that. But I do know that AH is now 16 plus 9, 25. So I could even, AH is 25 centimeters. I can use that to help find AE. So I have basically 2 secants. So my rule was whole times the outside equals the whole times the outside. So for this, I'm going to say AL is my whole times my outside AE, my unknown, equals the whole AH times the outside AF. So 36 times y has to equal 25 times 16. So 25 times 16 is 400. 36y equals 400, so divided by 36. Now on yours, you're probably going to come up with, again, different numbers because I changed mine. Most of yours are going to be whole numbers. There are, I believe, 2 or 3 answers that are decimals. But this is what I'm looking for. Your answer, 1 point, your work, 2 points. On some of these, it's going to be using things that you know about isosceles triangles, inscribed angles. Measures of the intercepted arc are twice as big as the measure of the intercepted angle. Some of them are going to be theories, and so if you wanted to write as your justification for some of these, theorem 9 dash whatever, that's a good reason. Your justification could be that the diameter is twice the radius. That's a good enough reason for me. But you need to do these in order because you have to have, I think, B in order to do part C. So if you don't do B right, you're going to get C wrong. So go back through your lessons, go back through the Class Connects, go through your notes, look for those theorems that we talked about. Look for rules that we discussed and corollaries that we discussed. If you have any further questions, please don't hesitate to send me an email or come to Help Lab.